Welcome to Deep Engineering Interview Series, where we bring you insights from engineering leaders building the future of modern software. Today, our guest is Peter Zaitsev, co-founder of Percona, and now a board member and advisor across a range of open source startups. Peter grew Percona from a two-person company into one of the most respected names in open source databases, and he co-wrote High Performance MySQL. Today, we are talking about how engineering teams actually choose their databases and design the infrastructure around them. Welcome, Peter.
Hey, welcome.
Good. Thank you for your time. I'd like to give you the floor first. Please tell us a bit about yourself and your journey with Percona and what you're focused on now.
Yeah. So I started with databases now more than 20 years ago, and been running Percona for 20 years. We help customers to choose, deploy, manage databases with focus on open source. As a company, we started with MySQL, but now cover the most popular open source databases.
Interesting. With that, let's just dive deeper. When you look at what engineering teams are reaching for in 2026, which databases come up most, and what is driving those choices at the technical level?
Well, if you look at the databases the most commonly chosen right now, I would name Postgres. It is by far the most popular database chosen by engineering team those days, and that happens both due to technical and a lot of non-technical reasons as well.
Yeah. And where do you see teams picking the database for reasons that do not survive, let's say, contact with real load, and what should they weigh instead?
Well, I think a lot of people choosing a database maybe without a lot of thought, right? Hearing from what a friend is using, right? Or they read about some conferences and so on and so forth, right? And relative database is interesting, right? If you're building the basic applications, you can do that with pretty much any database. Choose MySQL, Postgres, Mongo, even Oracle, right? And you can build your application. Now, if you're building something more special purpose, high performance, high volume, you have to be like very cost effective. That is when you have to give a database choice a lot more thought.
That's helpful. Thank you so much. Now, the next question that I want to ask is maybe you could just shed some light on, probably just tell us about Stack Overflow's developer surveys that have put PostgreSQL at the top for professional use for a couple of years now. So from your years of experience and also your involvement in the open source community, what do you think that Postgres, got right to earn that spot?
Well, if you look at the Postgres, right, I think there is a lot of technical and non-technical reasons which set for Postgres. If you think about their non-technical reasons, right, which I think frankly is the most important here, is what the PostgreSQL is truly community database. Nobody owns Postgres, right? And what that meant, what that allowed everybody in the industry cooperate on Postgres. You think about, Amazon, Google, Microsoft, right? A lot of others, they can offer PostgreSQL as their own, right? There's like a level playing field for those companies versus if you are promoting MySQL or promoting Microsoft SQL Server, right? That is something which is owned by some particular customers, right? And you're sort of giving your competitor more power, if you will, right? That also helped PostgreSQL to be ubiquitous, right? You can see there is a PostgreSQL event probably happening every week, somewhere in the world, right? Because there are so many people interested in promoting technology like Postgres, right? And then if you think about from the technical standpoint, the PostgreSQL is very good in terms of modularity, right? In terms of building PostgreSQL extensions. So if you think about what has been happening in the industry, for example, you can say, hey, time series databases are good. Well, PostgreSQL can very quickly provide an extension to deal with that, right? Or of course, more recently, AI, right? Well, pgvector, vector search, enabling building AI application with Postgres that came about very quickly together with a number of other extensions for the field, right? And that is the very important technical reason why PostgreSQL is winning.
So, and where is Postgres actually landing in production today? And maybe you could tell us also which workloads are teams still wrong to put on it.
Well, PostgreSQL has a lot of very big installations those days, right? You can find a lot of PostgreSQL ranging from their general web application to a lot of in financial and banking sectors also are using Postgres. So that has again a very ubiquitous, very scalable general purpose database.
Interesting. Let's also talk about sovereignty and open source on the technical side. So data sovereignty and open source licensing are shaping deployment decisions right now. So tell us maybe about the technical constraints they introduce and where do they force an architecture change rather than just a policy one?
Yes, yeah. Well, I think you touched an important point here because when they talk about choosing a database, right, it's often chosen in the context of the platform, right? And often what we see is what customers are making some high-level decisions where we go, and that maybe, hey, we are going to use, let's say, AWS for the cloud for everything, right? And then that's going to drive database choices, right? Maybe we will follow what that cloud suggests, right, to use, right? And then that's maybe Postgres, but that's maybe let's say the proprietary version of the Postgres what Amazon provides, right? And I think that is important to see for your organization what you think in terms of your data sovereignty, data independence requirements, right? As well as what kind of controls you want to have in terms of cost, for example. What we see in this case is this kind of separation, right? For a lot of startups, they go there and they say, hey, we just need to build as fast as possible, right? Like they're going to go and take this kind of an easy button, wherever that's going to be Amazon, right? Or maybe you'll go and Supabase, right? Or something like that, right? Now, a lot of the larger organizations, they often have to think about the cost, they have to think about the compliance. If they have like a massive multinational operation, they have to think about following local laws, and they can say, well, you know what? We actually want to have more in control, right? And that often brings them more to the open source side of things, right? That is where we may see them running Postgres in a cloud native way, right? For example, using Kubernetes-driven environment, which on one extent allow them to have a very high level of the automation, similar to what managed cloud vendors can provide. On the other hand, to be completely in control of their database.
Interesting. Thank you so much. That is a helpful answer. So tell us also from your experience, when a project licenses or a vendor closes up, what does that actually cost an engineering team, and how do you design to keep that exposure probably low?
Well, yes, you're actually, I think, an important point, because what has happened in the last few years, right, the people either kind of lost trust to open source or start to understand that open source is not enough, right? You can see some companies, for example, MongoDB, they have open source database, and then they change that and say, oh, now it's going to be not open source. It's maybe source available. It's maybe entirely proprietary, right? There are some also you would find open source companies which would shut down, right? And then you can find that the open source software exists, but it's not maintained, and so that is not really safe to use in production, right? So then you are choosing the open source software. I think first you really need to understand what that is open source. A lot of companies right now are trying to trick you using words like, oh, this is their open source compatible software, right? Well, now that means that's actually an enterprise software, which is not open source, but it has some level of compatibility, right? To use a word like open core, that means, again, there is some sort of maybe limited, crippled version of software which is open source, but what they actually want you is to buy the proprietary version of a software, and so on and so forth, right? And then you need to really understand what you are buying, and open source is best for you. The second reason I think is very important, and that is why PostgreSQL is big, is having a big community, and community also of vendors. Because if you choose open source project, you can hire many companies to help you. You can find Percona, right, for example, and to choose to give us your business, right? But if you don't like us, like we are too expensive, quality is not good, you can go ahead and choose somewhere else. While if you choose proprietary software, you don't have that option. If you are running Amazon Aurora, well, only Amazon can really help you with that product, right? And it comes on the deep experience, right? And I think that is an important point. And I think in many cases, because like in an early stage, engineers so focused on building their application, kind of moving fast, getting to the market, they don't think about those, right? And I'm not sure all of them should, right? Because if you're in a startup environment, there are a lot more reasons for your startup to die compared to overpaying for your database. But I think as things transition to kind of more mature environment, those questions should be asked. Because what you can also see, what there are a lot of enterprises, they started this kind of very painful migration away from Oracle, for example, a decade ago. And many millions of dollars, many years, they still own it because databases are very sticky, right? So if you really have made those choices and have built a very complicated databases focused on locked in on certain database technology, it's maybe hard to move.
Interesting. Thank you. I also want to shift gears towards security sides of things over here, because yes, open source is great, and there are high velocity open source technologies and projects. And yes, when there is something that is useful and solves a problem, a lot of people are going to use it, but some are going to trying to break it, right? So we have to consider that side as well. So let's just talk about maybe the security side of things. For instance, self-hosting an open source database, puts the security burden on the team itself. So what do you see teams maybe they underestimate there, from patching cadence to backporting fixes into an older version they are stuck on?
Yes, well, of course, right? Security is critical. I think especially now, right? Because with AI, the security holes can be found and explored at the speed which was never seen before, right? And yes, I mean, if you are taking the responsibility on yourself, right? So, or choosing some vendor to do it for you, you need to make sure what this policy is very strict. And I would say it's also very important to have this kind of multi-layered security approach, right? Because when it comes to the security, like nothing gives you 100% guarantee, right? Like in this case, you can see even some of the most serious environments kind of being explored, right? And I think that's means what you need to make sure you not only have a sort of defense, like, hey, what the process we have to ensure that will happen, but also if an incident happens, how we react to that, right? I think that is as much important, right? And I think that is also this very specific experience here for many teams, even if they choose to not go in with fully managed solution for a cloud vendor, to work with some particular vendor to help them with the security policies, to make sure what you have somebody you have a contractual relationship with, right, to help you with security patching and so on and so forth. And again, in many cases, when it comes to security, that becomes not just a technical question, that becomes also their compliance compliance question for a lot of large organizations.
Yeah, and would you in that scenario consider managed cloud databases?
Well, look, the managed cloud databases, right? They are not bad, right? They're a good choice for a lot of folks, right? And as I mentioned, they have a lot of the trade-offs in this regard. When it comes to security, yes, they allow you to push more towards their the vendor, right, who is responsible for managing your managing a database. That is probably something it's important to remember. When you think about the number of a database, the number of choices how a database deployed in the market, this is actually illustrated. There is no one size fits all answer.
Yeah.
Right. It's not like saying, hey, you build an application, you need a database. Here is the choice, right? Then you choose this database, you run it this way in this operating system, you use this programming language, right, and so on and so forth. That's not how it works. Right? There are a lot of consideration in the real world. Consider.
Interesting. We did a bit of a meandering around security. Let's just get back to talking about relational databases. So teams are running document, vector, and graph databases alongside relational. So which of these earn probably a dedicated store, and which are teams adding on hype rather than a real workload need? You might have noticed a lot of conversations around these things in open source communities and conferences.
Yes. Well, what I would say, it is a combination of technical and not technical reasons, right? Because when you think about the engineers, a lot of them, they like to explore or play with the new technologies, right? Maybe heard something in conferences, right? They, read some podcasts. This is something, very cool, very, very quick, right? And that's how a lot of technologies get introduced. In my experience, the more technologies you introduce, the more complexity it creates, right? Like if you are a 5-person company, right, and you are self-managing, 10 databases, right, there's probably, way too much complexity you create. What I would suggest is starting with something like in a PostgreSQL is often a good choice, right, and seeing how far you can take it. PostgreSQL can store serious data, it can store, documents, it can of course store vector data, and then maybe you find what in terms of the scale or some features you need some special purpose database, and then you can say, well, you know what, actually I will go and use a special purpose database for this given workload, right? And I think that is what is important to remember, right? Because a lot of companies, they aspire and learn from a company of a giant scale. Hey, what is Google is doing, or Facebook is doing, right? Or OpenAI is doing, whatever, right? But those companies are operating on so different scale. They are in a different universe, right? And what I would think about, like, if you're hearing something what Facebook is doing, and you are a 3-person startup, this is most definitely what you should not be doing, because they operate on completely different scale. But for a lot of engineers, right, from non-technical standpoint, it's kind of nice to do what the cool kids are doing, right? Oh, I'll go and do the same stuff what I call the engineers from this, some famous companies are doing, and try to do the same.
Yeah, that makes a lot of sense. And also, vector databases specifically have exploded with the AI wave. And where does a purpose-built vector store beat adding vector search to Postgres or an existing engine?
Well, I mean, if you think as if any database, right, which is purpose-built for particular task, it can often do better, have more optimized store, have some sort of language, right, which is better for that, right? So that is quite common. And before vector storage happens before, right? You could see, like a document-focused databases, right, or time series databases, what we mentioned so far. I think what is very interesting in the vector databases, right, is the AI is moving so quickly, and it is kind of really becomes the questions. Okay, what exactly features do we need for building those kind of AI applications, right? What exactly that kind of vector do we need to do beyond the vector search, right? And often we talk about, the database you want to store vectors. Okay, of course, right? You may be able to search them. Okay, that's fine. But what else do you want database to do, right? Maybe you want that to be able to do some more, broad functions that ranging from, embedding generation, right, or even provide some sort of like a high-level functionality, right? Do we focus on a low level, what is a vector search, right? Or do we want the application which can say, hey, I want just a database to speak natural human language, right, and have all that kind of intelligence, the frontier models bring, right, but also all the enterprise or domain expertise knowledge we have, right? Is that a database part? Is that an application which is going to be custom built? Handling that is a lot of still that kind of evolving how that architecture is going to look like, right? And if you go to the AI database, right, I think the advice here would be kind of slightly different, right? Because if you think about the mature relational databases, right, this technology is many decades old, right? I think I think MySQL celebrated, what was it, like 30 years, right? PostgreSQL is somewhere in the same stuff, right? A lot of things in the core, they are sort of really already decided. That is how we build that. The AI world is completely different, right? Every 6 months, things drastically change, right? So when you are building AI applications, right, you really want to look at the dates, right? If you're looking at some best practices which are year old, well, they probably will be very good advice still for MySQL or for Postgres in general, but for building AI apps, that's maybe too outdated at that point, right? And you need really to.
Interesting. And if you are advising a senior engineer building out data infrastructure this year, what is a decision you watch them probably get wrong, and maybe what advice would you give them?
Well, again, I think the advice would be probably just making sure to understand what the needs you have. And right now, actually, with AI, it's kind of very, quickly, right? Even if you kind of can write it down and say, hey, these are kind of like really requirements I have, right? You can actually, ask AI to say, hey, what am I missing, right? And obviously kind of get that some advice, in this case, what you can consider, right? I think in way too many cases there, choice about what database is Danker has a very quick consideration without a lot of thought. And as I mentioned, the databases are very, very sticky, especially if you're building an application which is going to last for many years and on the large scale. So yeah, make sure to give it some thought.
Definitely. Peter, I think we've come to the end of our discussion today. Thank you. This really has been a useful conversation, and thank you for explaining in depth.
Okay, I appreciate it. Thank
Okay,
you.
great. So for everyone watching, you can find Peter on LinkedIn. We have his LinkedIn link in the newsletter issue, as well as in the description below. That's it. Thank you so much for joining us today. Goodbye.
Okay, thank you.